So we had been talking about simplifying radical expressions. We're going to continue kind of doing that today.
Wait, can I go to the bathroom real quick?
You may. And we've dealt with like how we multiply and divide radicals, right? What operations do we still need to talk about, though? Addition and subtraction, right? Okay. So to add or subtract two radicals, we need exactly the same kind of radical. So what do we mean by same kind? Let's kind of just demonstrate here by example. Okay? So square root 2 plus square root 3. Is that the same? Nope. Why is it not same? One of them's the square root of 2, the other's the square root of 3. Okay with that? They're not exactly the same. So what if I did the square root of 2 plus the cube root of 2? Is that the same? Nope. Why are they not the same? Yeah, the indices are different. One's a square root, one's a cube root. What if I do the square root of 2 plus the square root of 2? This is the same. So how do we add them then? We're going to add them like we would a variable and just add the coefficients. So what's the coefficient in front of this square root of 2? A 1. What's the coefficient in front of this square root of 2? So when I add them together, 1 plus 1 is 2 square roots of 2. Everybody okay with that? Okay. So what if I did 3 cube roots of 7 minus 5 cube roots of 7? Can I do that? The radical parts are exactly the same, right? In both cases, we have a cube root of 7. So to do this subtraction, what am I going to do? Just do 3 minus 5, which is negative 2. And then I have still the cube root of 7 tacked on at the end. So it's just like adding or subtracting variables, right? Where the coefficients change, but the variable part stays the same. Feel okay there? How about the square root of 2 plus the square root of 8? Can we do this?
Yeah.
Yes.
The square root of 8.
While it doesn't look at first glance we can do this because these are different radicals, perhaps the square root of 8 can be simplified so that it is the same radical. So remember, 8 is 2 to the third. So what can I take out of the square root of 2 to the third? 1, 2. And how many 2's are left then under the square root? One of them. Can I add these together now? Yes. What would I get? 3 square roots of 2. Everybody so far so good? Okay. What if we have, oh, excuse me, cube root of 16, or let's say 3 cube roots of 16 minus 5 cube roots of 128. Can we subtract them as they're written right now? No. Could we possibly be able to subtract these, though? Yeah, maybe. We'd have to simplify the radicals, though, to find out. So let's do that. What's the prime factorization of 16?
4.
You mean 2 to the 4th. What's the prime factorization of 128?
7 to the 13.
2 to the
2 to the 64th.
2 to the 64th is like got 10,000 digits probably at least to it. I think you're thinking 2 times 64.
Yeah.
2 to the 64 is a very different problem though. So you want to, do we need to write it down? We can write it down. 2 and 64, okay.
8.
Sure. And 8 was 2 and 4, and 2 and 2. So let's see, 1, 2, 3, 4, 5, 6, 7 of them. Everybody good? So looking at the first radical here, how many 2's can I take out? 1. How many would be left? How many 2's are left? 1, right? I had 4. It takes 3 to get 1 out. 4 minus 3 is 1. Let's look at the second radical. How many 2's can I take out of that one? 2 of them. And how many 2's are left? 1. Is everybody okay there? 7 minus 3 is 4, and I can subtract 3 again, and I'd have 1, right? Okay. So when I simplify this down, I have 6 square root 2 minus 20, cube roots 2. And 6 minus 20 is negative 14 cube root 2. Is that okay? Let's do another then. How about cube root of 108 minus 10 times the cube root of 32? Can I subtract these as they're currently written? No. Might I be able to subtract them still? Maybe. How would I know? You got to reduce the radicals to find out, right? So to reduce the radicals, we have to do the prime factorization. So what's the prime factorization for 108? Four and 27. And then 4 is 2 and 2. 27 is 3 and 9. And 9 is 3 and 3. Everybody feel good there? Okay, how about 32? Okay, 8 and 4. 4 is 2 and 2. 8 is 2 and 4, and 4 is 2 and 2, so that's 2 to the 5th. Everybody happy with that? Looking at the first radical, what can I take out? 1, 3. That's correct. What's left underneath the radical after I take out that 1, 3? Just the 2 squared. Okay. Then let's look at the next radical. What can I take out of that one? 1, 2. What's left after I take out that 1, 2? 2 2s. Is everybody okay with that? So that gives me 3 cube roots of 4 minus 20 cube roots of 4, which is really just negative 17 cube roots of 4. What do you think to that? Yes? Okay. Do we still need a minute? We can wait for a minute if you're still thinking. No? We're okay? If I get going too fast, just say something. We can slow down for a moment. It's okay. You know? Okay. 7 fourth roots of 648 plus 11 fourth roots of 5,000. What should I do first? Prime factorization, okay. 648 breaks up into what two numbers? 2 and 3, 24. Everybody buy that? 2 and 162. I think, nope. Oh, yeah. Yeah, 162. Good. And then 2 and 81. And then 81 is probably 9 and 9. And there's 3 and 3. So I have 2 to the 3rd and a 3 to the 4th. Let's do the 5,000 now. How about 50 and 100? Sound good to you guys? 50 is 5 and 10. 10 is 2 and 5. 100 is 10 and 10. And 10 is 2 and 5, and 2 and 5. So that's going to be 2 to the third times 5 to the fourth. Are we all happy with that? I know I rocket through some of those prime factorizations, but again, if I get going too fast, just holler at me. I'll slow down. You know, I just get excited.
I feel you.
Thanks, Tommy.
God, I love math.
It's a beautiful thing. All right, let's look at that first radical. What can come out of that first radical? 1, 3. And what's left then after we take out that 1, 3? 3 2's. Good. Now let's look at that second radical. What can come out of that second radical? 1, 5. What's left after I take out that 1, 5? 2 3's. So I have 21 4th roots of 8 plus 55 4th roots of 8. When I add those up, I get 76 4th roots of 8. What do you guys think? Not that bad, right? We'll stop